Hello, my name is Fabio. I'm an associate professor here at CFPR. This is the CNC lab. CNC stands for Computerized Numerical Control Machine or machining. All that you see here is about mechanical things with a digital brain. Here we make things. We make things for other departments. We make things to update and upgrade and hack our own machines, and also we work with external companies, industries, artists for collaborative projects. So I will guide you through these technologies by showing you 4 projects that we have done in the recent past, mainly during lockdown. So the first project is here on the left, and it's called Unesco for All. It's a project funded by the European Commission. The aim is to let 4 UNESCO sites around Europe more accessible for all. The 4 UNESCO sites are in Spain, Italy, Russia and Bulgaria. And what we have done is to replicate some architectural and artistic features to let them easily understandable for public of blind people. In this case, we made this object using 2 different machines and 2 different technologies. One is subtractive, where you go with a drill basically and you remove material from a block, from an entire block, exactly how a sculpture would do. And the other technology is instead additive, so you add layers of material. In this case is resin that you cure with an UV light, and combining the 2 technologies, one is subtractive and the other is additive, you overcome the limits of both technologies and you get both best result from both worlds. The second step was then to use more traditional techniques to replicate the features with silicon molds and plaster casting. In this way we could have a consistent material, even if we are using different technologies. It's nice to touch. I mean, it's different plastic for a blind person, and it's rich in terms of content, and it's affordable and easy to replicate, easy to maintain, easy to clean. The last part of this project was to add sensors. Like these are NFC sensors, cheap and common technology, passive sensors that you can put directly into the object, so they are hidden into the object, and the purpose is to trigger with a bespoke small piece of hardware that we developed to wake up these sensors and to send directly to your smartphone their identity. So just as a standard visit, the blind person wears a ring, it navigates through an object, so it touches the object, and when it goes to an hotspot, he has a relevant information of the feature that is touching at that specific moment. So basically you touch the object and you receive an audio comment which is relevant and precise in your own language directly on your smartphone in less than 1 second. This has been really well received by the blind people community, because it's a step forward. Normally they can receive information through tactile exploration or through audio guides. In this project we put them together, touch and hearing at the same time, and they really appreciated also the easiness of this system. This project has also been awarded by the European Commission, and it won a special prize for this category. Projects number 2, 3 and 4 are instead made using Cobots. Cobots are collaborative robots. As you may see, I can just touch them, work along with them without any risk, because they are not harmful. They stop in case they hit you. And mainly for collaboration with artists, they are useful because you can literally work along with the robot. With these Cobot, we are working on a project, the one over there, where we use robot to basically scan any object using a low poly scanner that is mounted on the robot as an end effector. So in that robot right now we have an extruder, but you can virtually put anything you want. In this case is a combination of low cost 3D scanners and standard cameras. So we can acquire both the geometry and the texture of any object automatically with a Cobot. Another project here, again with Cobots, is this one. Is a collaboration with an artist from China. The purpose was to replicate the human movements while writing a poem in traditional Chinese calligraphy. So we worked along with this artist, and we decoded all the movements of a hand while writing the poem, and as a result we have a perfectly matching outcome. So on one hand you can see the artist writing, and the other hand you see the machine writing, and it's almost the same thing. We have done it with algorithms, so we program the movement after examining all the movement from the artist. The future will be using computer vision and machine learning to learn directly from the source and to get all the errors and all the movements from any human without having to interpret it with an algorithm. Project number 4 is that one. Is still an ongoing project. Is a project for an international artist of great reputation. It is a non-disclosure agreement. There's a non-disclosure agreement that protects these projects, so we can't tell you anything. I can't tell you anything about this project, but I will try to describe it in any case. The artist came to us, he wanted a large sculpture made with a robot, like if you were drawing in the air. Unfortunately, this is not possible because when you use a filament, the filament is soft, and while you are drawing, the filament drops down because of gravity, and also because when you extrude, the filament is hot and is absolutely tender. Another problem is that the robot may have self-collision, so it could collide within himself or directly with the sculpture that is sculpting. So we ended up with a system that is dividing the complex structure into more in simpler parts, and instead of using a standard slicing method which uses a lot of plastic, we use temporary scaffolding that are automatically built, dealing with the geometry that is underneath. So in this case, the collaboration with the artist was extremely useful because it forced us to see things in a different way. Normally you would slice the model. In 3D printing is the traditional approach. The artist didn't want this kind of cheating method, so forced us to find another way of doing this. Has been a successful first phase of our project. As a matter of fact, right now we are in phase 2 of the project, and hopefully we will see the result of this research and of the artist poetry in some international venue, in some museum. Last but not least, the machine there is again a CNC machine. It's a new piece of equipment. Is the last acquisition of the CFPR in terms of technology. Is a monster, even if it's an acquired technology. CNC started in the early 50s, but this one is absolutely an outstanding piece of hardware. I will leave Michael White to describe and to tell you something more about this technology.
I'm Michael White. I'm a technician here at Centre for Print Research. I'm going to show you the CNC machine, the Haas VF2 SS, and tell you a bit about what we're going to use it for. This is a brand new machine to us, and it's an industry grade machine. It's a very fast one. The SS in the name stands for super speed, which allows us to use this as a kind of rapid prototyping machine, as well as a machine that will give us professional finish on our products. We do a lot of bespoke and custom tool making for a lot of the research projects that happen here, and this machine is going to allow us to develop on that and create custom tools out of metals like aluminium and steel, as well as brass, which we're using for a current project creating augers to extrude clay. This machine has a fourth axis, which allows us to rotate the stock that we're working on, allowing us to create these augers. And the machine has a super high precision, as well as a large bed, which means that we can work on things precisely on a large scale, such as architectural things, objects, down to a small scale such as sensors. So that gives us a huge variety of projects we can have this included in. This machine is super precise, down to sub-micron levels potentially, which gives us the opportunity to use it to create sensors. And on the other side, we also want to use it to create copper plates for traditional printmaking, which allow us to have that digital integration into traditional printmaking techniques, which is something that CFPR holds as a core value.